Okay, so this is page 218, lesson 7.4, guided practice. We are here with third hour. You guys can say hi if you want. Hi. Can you hear the enthusiasm in the voices of these amazing 8th grade math students? Okay, so we are building on lesson 7.1, 7.2, 7.3, 7.4. 7.3 into 7.4. What we have done in our previous lessons is we have been solving equations that have variables on both sides. We added rational numbers in, we added the distributive property in, but we were still just solving for x. Every equation that you have solved up to this point had how many solutions? Every equation that you have solved up to this point had how many solutions? 1, right? Because it always ended with x equals a number, right? True? Okay. So what we're doing now is we're taking equations that could have more than just one answer. They could have many solutions, and they could have no solution. So if I jump over here to yesterday's notes real quick, if you guys got them, what that essentially means is that you guys have been given equations that have had, if you were to graph them, one point of intersection, right? So if you're visual, this is kind of like what this means. This is what we're doing, right? So up to this point, they've only had one point of intersection. Now you guys are doing equations and solving equations that could have many solutions, like this, where ultimately they're the same line. So when the same line and they're set equal to each other, they have many solutions because they're constantly overlapping and they're constantly intersecting. So any point could be a solution. So far, so good? Okay. You could also have equations when set equal to each other have no solution. They will never intersect. They will have no point of intersection. So no point will ever make this equation true. Right? So that's the big picture of what this means. So if we jump over here back to our guided practice, we're going to use the properties of equality to simplify each equation and tell whether the final equation is a true statement. Okay, remember, you can have a true statement that has one solution, and that's going to look something like x equals a, where x is a number, right? X equals any number. You can have a true statement that has a equals a, where you have one number equals itself, right? That's still a true statement. You could have a false statement where you have something like 3 equals 4. And it is false because 3 is never going to equal 4, is it? And 4 will never equal 3. Question? Yes, absolutely. You should be doing this. This is your assignment. We're going through together. Yeah, you should be following along. Okay? So let's take a look at number 1. First thing we want to do always when we're solving equations set equal is first see, is there any fractions we have to eliminate? Yes or no? No. No fractions. Any decimals? No. Any parentheses do we need to distribute? In this one, number 1. No. So then we just get to start solving by combining like terms, which means we're going to put our variables on one side and our constants on the other. So what is the first step they took for us? Yeah, they're combining the variables, adding 6x to both sides. So what happens on this side? Yeah, it zeroes out. It cancels out. What happens on this side? 3x plus 6x. 9 what? 9x. So we've got 9x. We bring down minus 2 because we didn't change anything. Bring down the equal sign. We didn't change anything. And then on this side we have 25. We didn't change that. So what do you do now? What's the next thing? Yep, and that is combining the, what do we call those? Yeah, constants. So we're combining our constants now. So we're going to add 2 to both sides. On this side, it zeroes out. It's canceled, right? It's gone. And on this side, we have 25 plus 2. 25 plus 2 is? Yeah, 27. Did we change 9x? Nope, so we just bring that down. 9x. What happens next? Yeah. Because this is essentially 9 times something equals 27. Multiplication, the inverse operation would be division. So we have 9x equals 27. We divide by 9. Why do we divide by 9? Yeah. Well, what is 9 divided by 9? 1. You are left with 1 x. What's 27 divided by 9? 3. So we have x equals 3. This statement is true. How many say true? How many say false? You guys are good. This statement is true. Why? Exactly, yeah. Because you can solve this equation. You have a solution. There is a solution. There is one point of intersection if you were to graph these lines. So this is a true statement. If you were to plug this back in, you could see that it makes a true statement. You would plug in 3. Do you guys want to do that real quick? Plug it back in. So if we go 3 times 3 minus 2 equals 25 minus 6 times 3, right? Because I just substituted x for 3. What is 3 times 3? Minus 2 equals 25 minus 6 times 3, 18. So 9 minus 2 is, and 25 minus 18 is. Is this a true statement? So this solution is correct. Aha, so we know it makes sense. It's a little tangent there. So this is a true statement. How many solutions do you have in this one? One solution. The only solution you have is 3. 3 is the only thing that will make that equation true. So let's jump over to number 2. We have another equation where we've got variables on both sides. First thing we do is check for fractions. Do we have any to eliminate? No. Do we have any decimals? No. Do we have to distribute? No. Yes, we do have to distribute. We are distributing what? Yeah, right here. 2 times x minus 2 times 1. So 2 times x is what? 2x minus 2 times 1. Okay. What do we do now? Combine the constants. So whenever you distribute like this, you want to double check before you start moving things across the equal sign to see if there's anything on the same side that you can simplify. In this case, there is. You have a negative 2 plus 3. You have these constants on this side. So what would that simplify to? Positive or negative? Right? So plus 1. Now, it's simplified. We need to combine like terms on opposite sides of the equal sign. We need to get variables on one side and constants on the other. What do you want to move first? 2x. So minus 2x, uh-oh, what happens? 2x minus 2x cancels out. That's 0, right? And on this side too, 2x minus 2x, these cancel out. That's 0. So what do you have left? Negative 4 equals 1. Is that a true statement? No, that is a false statement. Why? Exactly. Negative 4 is never going to equal 1, and 1 is never going to equal negative 4. Those two numbers will never be equal to each other. So this is a false statement. When you have a false statement, how many solutions do you have? 0. No solutions. And so if we were to just kind of do a little higher order thinking here and look back at this point right here, do you notice that you have 2 variables here? This is the same slope. Thinking back to our linear equations, this is the same slope here. So they're going to run parallel to each other, but they have different y-intercepts, so they're going to run parallel and never intersect. Okay? So far so good? Making a little more sense? So let's jump down to number 3. How many solutions are there to the equation in exercise 2? No solutions. We already determined that, right? Number 4, after simplifying an equation, Juana gets 6 equals 6. Explain what this means. What does that mean? First of all, what kind of statement is it? True. It's a true statement. 6 will always equal 6. That's a given, right? When you have a true statement, you can either have one solution or many solutions. If you have one solution, you're going to have a variable that's equal to a specific number. If you have many solutions, you're going to have a number equal to itself. So how many solutions does this have? Many, right? That means that the equations that gave you this solution are the same line and they would lie on top of each other. So this is many solutions. If we think a little further, this tells us that any value of x that you put into that equation will make the statement true. Any value of x that you put in is going to give you a number equal to another number. Yes?
Will we ever get a problem that asks how many solutions?
Uh-huh. Oh, asks how many? Specifically how many? Well, no, you won't. No, you're going to have either, in this lesson, it's either going to have one, many, or none. All right, so the next thing that you have to do in this lesson is write an equation given a number of solutions, okay? So if we think back to the lessons we have been doing, this is like where you had to create a real-world situation from an equation that was given, right? So it's part of that working backwards. The reason it asks you to do this is because it doesn't just want you to understand process, it wants you to understand the meaning of the process. It wants you to understand what it is exactly that you're doing in the process, not just kind of that rote memory. So when you write a linear equation with one variable that has infinitely many solutions, what do you start with? What kind of statement? A true statement. If it has infinitely many solutions, it has to be a true statement. So you're going to start with a true statement. In this case, they gave us 10. In order for this to be a true statement, with infinitely many solutions, what do we have to put here? 10. What do you think we do next? What does it show us there? We are going to add blank to both sides. Yeah, what do we call that? What do we call x? X is a variable. So here's my next question. Do we add a different variable or the same variable? Right? We got to keep it balanced. So we have the same variable. So on this side, what am I going to have? One more time. What am I going to have on this side? Yeah, the same thing. Right? Because I had 10, I added a variable, the same variable to both sides. What do you think you do next? Add the blank to both sides. What did they do? They added a what? Constant. Same or different? What do you think? Same, because we are keeping things balanced. Okay, so this side is going to look the same as this side, right? Still balanced. We have to keep it balanced because this is an equation that's supposed to have infinitely many solutions. Yes? Okay. And the last thing that we do is combine. Yeah. Combine like terms. So what does that mean? What are similar terms that you can combine here? Yeah, 10 and 5. So what is that, when you combine those, what is that? 15. So now you have 15 plus x equals 15 plus x. You could write x plus 15 too. That would be fine. It's the same. So now you have an equation that has infinitely many solutions when you solve it. Good? Is that simpler now? So let's take this a step farther. In our essential question, give an example of an equation with infinitely many solutions, and then make one change to the equation so that it has no solution. Here is a place where I would like you to work smarter and not harder. Did we already create an equation with infinitely many solutions? Yes. Do you want to use that one? Okay. So we've got 15 plus x equals 15 plus x. Now we need to make one change so that it has no solution, which means we take a balanced equation and make it unbalanced. So there's a lot of options. Yeah, so you could take out an x, right? So then you could have 15 equals 15 plus x. Is that a true statement? No, this is a false statement, which means that this has how many solutions? No solutions. So we did one change to this. We just took out the x on one side. So we made the change so it wasn't a balanced change. So we didn't do it on both sides. And now we have no solution. What's another thing you could do? One change to this original equation. What's another thing you could do? To what? 34, right? Yeah. So you could go, okay, well, 34 plus x equals 15 plus x. If you were to solve this, you'd end up eliminating your x's, right? You'd get rid of those, and then you'd have 34 equals 15. Is that a true statement? No. That is a false statement. So that has no solutions. One more. What's one more thing you could do? Someone I haven't heard from yet. Grant? Yeah.
Oh, okay. 100 plus x equals 1 plus x.
There you go. Great. 100 plus x equals 1 plus x. Nice. So if you had to build an equation that had no solutions, do you think you could do that? Yeah, you just create an equation. It's not balanced, right? You could start with a false statement and build from there. You could start with a equation that's infinitely many and make one change. So you've got a couple strategies there. So the rest of your assignment is to finish 7 through 12. Okay? We've got a little bit more of an example here. Do we have any other questions on this before we move on? We're good? Okay, so if you get to your assignment later today and you want to watch this again, this will be posted on the website if you just want to watch it for review. It'll be up there. You guys want to say bye?
Bye. Bye.
I don't know if how much it's picking up, but